Morning. All right. We're at 2 after. We're going to go ahead and get started. I'll start with the introduction as some more folks trickle in here. So presentation overview. Thanks again for joining. Quick introduction. So we're TRC. The company name is TRC. We have a program called AESAP, is Agricultural Energy Savings Action Plan. My name is Andy Gustafson. I'm the program manager for our AESAP Energy Efficiency Program. I also have Tom McGinnis on, one of our senior engineers. We have Leslie from our marketing side and some folks. So welcome again. Just want to state this presentation will be recorded. So if for some reason you join late or have to drop, it'll be available to watch at a later time. So feel free to ask questions as we get through the go through the presentation, but please put those questions in the Q&A section. It's located next to the participants button on the chat function. So that chat function specifically, that's disabled. So please, once again, use the Q&A function, not the chat function for any questions that come up. Due to the time constraints, we only have a half hour. We're going to revisit those questions at the end of the presentation, but please, once again, use that Q&A function and feel free to ask those questions as we go through the presentation, and we'll revisit those. So we're going to do a program overview real quick. Then we'll talk about the meat of the presentation, which is really the winery refrigeration opportunities. And then at the tail end, we'll talk about how to apply contact information, and we'll get to the Q&A, things like that. So quick overview of our program. So once again, we are TRC. Our program name is Agricultural Energy Savings Action Plan, AESAP. We have a program, we won a contract, awarded a contract through PG&E several years ago to help manage the energy efficiency, provide incentives for the ag sector, including breweries, wineries, and distilleries as well. So we run that contract a few years back. Once again, we offer incentives. There's financing energies for energy savings projects related to whether it's retrofitting or installing new equipment, making energy efficiency upgrades, things like that. So our program, we serve all the segments, all the ag segments within PG&E's agricultural sector. We have services for calculating savings, processing incentives. We also have a component of our program that's related to demand side management. So we have services that can help customers enroll in like demand response programs. And actually we have some limited time incentives available for enrolling in demand response. So if that's something of interest, you can reach out to us and we'll help you enroll there. And there's actually some incentive dollars for helping you enroll there as well. One thing I really want to highlight is the services of our program are of absolutely no cost to the customer. Our program's vendor neutral. We do not care which equipment you go with as long as it qualifies for program rules. But yeah, no cost to you, to the customer. We have engineers here to support identifying opportunities and helping you ultimately make upgrades to save energy, and while being able to provide some incentives or financial support. So what we do, so we do detailed technical studies. We identify and evaluate those energy saving measures. We quantify those energy savings, those incentives, and the paybacks related to those. So if there's opportunities that you guys know of, or we identify something, we'll go in there, evaluate the savings, provide you with a payback summary showing like, oh, this is the payback with the incentive, so you can get a better idea if the measure makes sense for you, things like that. We also do the savings verification. So once the project's installed, we will measure and verify those specific energy measures and confirm that those requirements, the savings are verified and met. We also do financial incentives. That's the biggest part of what gains the most interest with our program, is we have incentive dollars that we can cut a check to you for doing these upgrades. So that's where a lot of the interest and the main driver of our program is customers interested in getting dollars to be able to help them do these upgrades. So that's a big part of what we do. In addition to just incentives, there's on-bill financing for qualified projects where you can actually get up to $4 million with 0% interest loans through PG&E. So the way it works is the energy savings for that measure, basically utility rate would stay the same until the energy savings would pay off that loan at 0% interest. And then once that loan terms are paid off, say it's 6 years to pay off, the energy savings take to pay off the cost of that loan. After that period of time, then you see those savings realized on your bill. So once again, that's 0% interest. There's also alternative financing options available if for some reason you don't qualify for on-bill financing. There's a Go Green and some other private financing options that are available as well. So wineries, once again, our program also serves the winery sector, which was the major focus of what this call is, specifically in refrigeration. Before we get into the refrigeration opportunities, I just want to say our program does have other rebate opportunities and incentive opportunities outside of just refrigeration. So whether it's at the vineyard, we have a rebate catalog with ag well and booster pump VFD rebates that's very popular with our program, as well as there's a rebate for putting in either a new pump or replacing a pump. There's rebates there as well, along with other rebates. So we're going to be talking specifically about winery refrigeration, but just know there's other incentives and rebate opportunities available as well. So to kind of segue into the refrigeration topic for today. So refrigeration systems are often the largest energy consumer in the winery. These systems are designed to meet full load, such as during the crush season when tanks and barrels are typically full. So the chiller would be running at near full capacity. But during those other seasons, the load on the refrigeration system goes down and lower than that specific design capacity. So because of this change in load, there are often some unique opportunities for some energy efficiency and savings opportunities there. So for the purposes of this call, we're going to be focusing on 3 refrigeration related measures with the program that we've been promoting and have had some success with, and just some key measures that we think would be good to highlight for today. There might be other opportunities there, but these are the ones we'll talk about for today. These specifically include glycol pump VFDs, floating head control, and VFD trim compressor. So the first measure is what's called a prescriptive deemed rebate opportunity, and this is for adding VFDs to the glycol pumps used for process cooling. When I say prescriptive rebate, I'm referring to the fact that the measure is pre-approved and no pre-approval is required to implement. We simply collect an invoice and the required documentation, and we cut your rebate check. So it's a pretty streamlined offering when we say rebate. This is for a situation where the glycol circulation pumps are running at constant speed. So this would happen even though the glycol is being bypassed from the wine tanks and recirculating right back to the storage tanks. So adding a VFD on those pump motors will decrease the glycol flow to reflect the actual load on the system. So the savings on these are realized similar to like with pumps, other pumps and fan things where it's called the affinity law, where the power is proportional to the cube of the speed. So therefore, reducing the speed of the pump, it results in reduction of the required horsepower by the cube root, resulting in the savings. So this will reduce the energy required to the pump on the glycols by adjusting the speed of the pump to the actual demand on the wine tanks. This is one that has some pretty good savings can be realized, and it's a pretty streamlined, easy to implement type measure if you have constant speed glycol pumps at your facility or working with facility that might have that. So as mentioned, this is a prescriptive deemed rebate. So therefore it has specific rebate levels and requirements that are shown here on this slide that's up right now. Some of those requirements include that obviously that the VFD needs to be on a constant speed glycol pump motor. So there can't be already have been a VFD in place or has a VFD in place. It's for one that's constant speed. Also, just a note that the chilled fluid, if it's other than glycol, it can be considered for the rebate, but only if the unit energy savings is equal or exceeds the unit energy savings for the measure. So if you have another fluid application besides glycol, I would just say reach out to our team and we can help confirm if it meets the requirements there. The unit energy savings basically calculated the difference between the energy consumption of like that constant speed pump motor and then the case for the measure. So as long as we can show that based on the horsepower, the load, and the operation and stuff like that, it could qualify. The table here on the right shows those specific rebate levels for this measure. And also I want to mention too that there has to be automated controls based on pressure feedback for the VFD to control that flow rate. So we need to collect that documentation for this, but Largely, if you just go ahead and you put the VFD in place, you send us a copy of that invoice along with the documentation for those requirements showed here and that are listed on our rebate catalog. We'll cut you a rebate check for it. And those rebate levels are reflected here in this table once again. So for example, if you have a 25 horsepower glycol pump VFD, that would be a $5,000 rebate. So you can have multiple of these if you have multiple pumps, and but gives you an idea of the rebate levels for that specific measure there. So that's glycol pump VFDs. The second measure we'll talk about right now is floating head or variable head pressure control, it's often called. This is a strategy which aims to improve a plant's refrigeration energy efficiency by optimizing both the head pressure and the intermediate stage pressure of the refrigeration plant. So often the refrigeration systems are run similar to like a kind of like a set and forget it type basis related to the plant's head pressure. So the lack of that flexibility in the head pressure leads to unnecessary energy consumption. Condensers are largely running oversized because they're designed to reach those conditions of the worst possible conditions the plant might see in the wet bulb temperatures. So under the current ambient conditions. So basically it's designed, the systems are often designed to meet that worst case scenario. But as you all know, like during a lot of the year, the plant condenser is under lower loads and the system is often wasting that energy. So the wet bulb typically fluctuates only with the change of the weather, while the floating head depends on the wet bulb of the plant. So a well-structured floating head system will dampen those head pressure fluctuations. So the reduction would also stabilize the head pressure of the plant, resulting in a more efficient and also more stable plant operation throughout the year. So as you can see on the slide here, it just highlights some of the benefits and key considerations there when we're looking at the floating head pressure, variable head pressure control opportunity. The next slide here, I want to highlight that there is a deemed rebate for floating head, variable head pressure control for just specific scenarios. So these scenarios include connected display cases, walk-in coolers, freezers, cooled storage, and prep area type situations. Subcooler loads and air conditioning loads are ineligible for consideration for this rebate, specifically the rebate. The rebate levels are shown. They're based on the tons of refrigeration capacity and the saturating condensing temperature difference, or that TD value there. So you can see that the rebate level ranges from $150 to $250 per ton of capacity. If it is a better fit, the measure can be processed what's under a custom incentive, which is shown here on the next slide that I'll get to. And our team is here to help determine what makes more sense, a prescriptive rebate or a customized incentive. They both have their pros depending on the type of application, and we can help with that there. The custom calculated approach would basically be providing an incentive. So if it doesn't fall under those conditions for that rebate that was shown there in our rebate catalog and that prior slide, we could process the energy efficiency measure what's under custom calculated. That's where we provide an incentive based on a calculated energy savings and also some other payback criteria from the customer, but largely based on the energy savings that we calculate through the measure opportunity. In order to do that, we would need some certain information in order to do this calculation. And that information would greatly help us with starting with that determination there. So I want to highlight some of those key information that we would need in order to calculate the savings potential. So the first one shown here is the refrigeration system serving the fermenter and storage tanks. So once again, those qualify for incentive, but we would need nameplate data for the mechanical schedule. So that would include the compressors, the condensers, showing the manufacturer, model, serial number. So basically those associated nameplates. So if it's easier, well, we can certainly go out to the facility and take those pictures ourselves. If anyone that's interested in this has like can go out, snap a picture of the nameplate of those key mechanical equipment there and send that our way, that would be a really good first start in able determining the savings potential. The other key thing we would need is trend data, the digital trend data, if it's available from the SCADA system or other system that might be in the control panel for the compressor system. So the key information there from that system, the data system we're looking for is the suction, the discharge pressure, the compressor amperage or power draw, the slide valve position for screw compressors, the condenser fan amperage and or percent speed. If you don't have a SCADA system or you don't have a system that can pull this trending data, that is ideal. If you have it, it just makes it a lot easier for us to do the analysis. But if not, we can certainly do data logging where you get data loggers, put it on there and actually record this information through a logging mechanism. But the SCADA system, if you have it, just makes things a lot easier. And often that the data from there can be a lot more accurate way of just being able to get the granular data that we need to really be able to do that analysis. So another important note is just that we need this data for both operating scenarios. So whether this is harvest and like a non-harvest system. So just to be able to get the data and the operating conditions for both of those load scenarios there. All right. Want to just briefly put up sort of a sort of censored project example that we specifically did with our program with a winery customer. Excuse me. This was a crush winery. They're located in California. They worked with TRC, our AESAP program, to do a floating head pressure controls. That specific measure with this customer saved nearly almost about half a gig, 500,000 kWh energy savings. Right about half a gig. It was, right around there. The cost savings based on their utility rate was about $81,000 per year. And the capital cost for doing that variable head control measure was about $35,000 for this specific scenario. So that gives you an idea of the project cost, the related savings and annual savings that you might see. We also were able to provide an incentive for this one of $17,000. So taking all those things into account, so the project cost minus the incentive dividing by the annual energy savings, the payback was quite good at just a couple months. So one thing I just want to highlight here is what we've seen historically, and it might not be for every scenario, but often a floating head pressure control type measure, the energy savings and benefits for that comparative to the project cost is quite good. The general project cost isn't typically that high and can result in some really good energy savings. So this is one of the type of measures that we often go after to try to get like kind of the biggest bang for your buck as far as energy savings potential there. So great measure that is definitely worth considering if depending on the type of operation you might have. Just doing a quick time check, got 10 minutes left. VFD controlled term compressor is the third measure we're discussing today. So many of the larger refrigeration plants we encounter, they use several compressors. And in a lot of those cases, the system controlling those compressors maintains and controls the capacity without necessarily optimizing efficiency. It's also common for us to sometimes see screw compressors that are unloading using slide valve control. And because of that, are often inefficient when operating at part load. Sometimes we see multiple screw compressors just running at this part load inefficiently. So there's some opportunity there. With the slide control, the reduction in refrigeration capacity of a screw compressor is relative to the power consumption, is disproportionate. So an example here would be like at a 30% slide position, the refrigeration capacity of the screw compressor is approximately at 40%, whereas the power consumption is excessive at approximately 60%. So this inefficiency is true whether the slide valve opens in a continuous manner or in stages. So if you have stages, say like 100%, 75, 50, 25, it still can be inefficient there. So The alternative to this type of operation is to use a variable speed drive to modulate the capacity of a compressor. The reduction in refrigeration capacity, once again, is relative to the power consumption. It's essentially equal, especially in the 40 to 80% refrigeration capacity range. This next graph here that we pulled in just for reference in this figure here shows the reduction in refrigeration capacity relative to the power consumption, how it's essentially equal, especially between that 40 and 80% range, as you can see here. So the energy saved is representative between the areas here on the line here. So yeah, I just want to highlight that that's another good opportunity. While not covered here in these three opportunities, I do want to state related to compressors, if there's refrigeration systems with multiple compressors, sometimes implementing compressor staging and capacity control can also result in some good savings. So like an automated compressor staging system takes into account the various compressors in the refrigeration class and progressively turns them on and off during the increased load or off during those decreased loads. So based on the suction pressure. So that could also be staging could also be a measure to consider outside of a VFD controlled term compressor as well. The next slide here just highlights that rebate catalog we mentioned. So a couple of the measures highlighted today and some of the ones we didn't necessarily dive into in those three measures, but there's other opportunities, like we said, the VFD on the ag well pumps, things like that. But you can find our rebate catalog at this link here. It's at our website. Our website is agenergysavings.com, agenergysavings.com. If you go to the type of incentives button up at the top and you go scroll down, you'll see a link directly to the rebate catalog if you need to navigate to it. But we'll also provide it in the copy that's going out with this. The invite for this presentation and follow-up recap you'll see here shortly to your email. Just know that the intent here is not just to point you to this catalog and let you figure out the requirements or what you need to do. Our team is here to help. It's just supposed to give you an idea and a resource to know what the requirements are and what the rebate levels are. So please feel free to check that out as a resource to get a better idea of those prescriptive rebate levels on what those are and the requirements for each there. Once again, these are for those measures that are prescriptive rebates and do not require pre-approval there. With that said, I'd still suggest you reach out to us, even though you might not need a pre-approval. It's always good if you're before ordering that equipment, you can always reach out to us so we can make sure the equipment you're considering meets the requirements shown. We're happy to help there. The application process is pretty simple. You can just email us or call us, but specifically for a rebate, just email us with a copy of that paid invoice, some general customer contact information, location information, things like that. The supporting, so we need that documentation, like a picture of the installation is preferred, it's not required, but send us an email with that information. We'll fill out the application for you and answer and call you and answer and talk with you about any questions you might have. We'll send you the paperwork and then for you to sign. And then once we have it, typically with a rebate, after about a month after we submit all the paperwork, we get that project paid and we cut your rebate check. So that gives you an idea of the timeline. There's only one application and a certification work. So just 2 forms you sign and we'll cut your rebate check. For custom incentive opportunities, I would suggest, so like the floating air pressure, some of the ones that are not on the rebate catalog, VFD compressor, maybe staging, things like that. Those are custom calculated incentives. Please reach out to us, email, phone, website, whatever it might be, and we'll work with you to determine the energy savings on that. It is very important to point out for those measures, it really requires early intervention for a successful project approval. We need to have a pre-approval before you purchase equipment, start on the project, or even ideally before even decisions are made. The whole idea is these incentives, we need to be able to demonstrate the incentives are helping motivate making this upgrade possible. So we need to be able to show influence, and it's important we're involved early so that we can document that through the whole process and make sure we have a successful approval. So once again, contact us. We'll talk through the details, and then we'll work to put together those savings estimates and see if we can come up with incentive that might meet your needs. Custom incentive also is just those two same forms, an application and a certification form at completion, and that's all we need to be able to have a successful approval. All right, we're at 3 minutes, and we can spend a little more time to go over Q&A, but here's our contact information. Once again, my name is Andy Gustafson. I'm the program manager. Tom McGinnis, who's also in line here, we're going to help answer questions. He's one of our senior energy engineers. We've been working together, man, over 16 years now, so we've been working together for quite a while, but we're really happy you're able to join today. Once again, this is recorded. We'll send it out for a future resource. But here's our website, email, phone number, everything here to be able to contact us.